It's just a geometry self-test, and so we're just going to step through a bunch of random problems. You can check to see how you're doing. Okay, press the pause button or the stop button right here. Try to work out the problem, and then you'll come back and you'll press the go button just to see how you did. All right, let's see how you did. If you got these answers right here, this is 40 degrees. It's an equilateral triangle, which means that the opposite angle will also be the same. These two right here, taken away from 180, 180 being the total internal degrees for a triangle. 80 taken away from 180 leaves us with 100. This angle right here is 180, so 180 minus 100 leaves us with this angle here being 80. Since it's an isosceles triangle, since it is an isosceles triangle, then that means also this is going to be 80. 80 plus 80 is 160. 160 minus negative 160 plus 180 leaves us with 20. So in other words, this 20, that 80, and that 80 right there all total to 180 degrees, which is the internal measure of all triangles in the known universe and beyond. Okay, see how you can do. Press on the stop button. All right, let's see how you did. Well, if you got this as 35 degrees, which is what it told you, then that also means that measure C1 is also 35 degrees. Subtracting both of those from 180, that leaves us with 110 left over. Any straight line is 180 degrees, so 180 minus 110 is 70. This is an isosceles triangle. We know that because of these two straight lines right here. And so if this is 70 degrees, then this is 70 degrees. Totaling those two, subtracting these two from 180, leaves us with 40 left over. And so we wind up having 35, 35, 110, 70, 70, and 40 as the internal degrees. Click on the stop sign, then come back and see how you did. All right. If you made a sketch that looks about like this, you're doing okay. Now, you could have been a little more detailed by putting in some things, but holistically, you get the picture here. The rise that we have is going to be 3, and the run is going to be 9. The reason for that is the rise is the change in the y value. So the 1, if we start at 1 and we go to negative 2, that's a total of 3 for our rise. Our run, we started at negative 4. We started over here at negative 4, and we went to positive 5. And so if you go to positive 5, that gives us a run of 9. If I then want to know what the length of my hypotenuse is here, right here, I can rewrite the number 3 under the square root sign. 3 and the square root of 9 are exactly the same number. They live at the same place on the number line. And then 9, written under the square root sign, is square root of 81. Adding the number 9, I'm not adding the square root 9, but adding the number 9 to the number 81 gives me 90. If I put 90 under the square root sign, that gives me the exact length of the hypotenuse. Now, the square root of 90 can then be broken down into the square root of 9 times the square root of 10. The 9 comes out from under the square root sign, and that leaves me with 3 square root 10 as the simplified version. Number 4, click on the stop sign and see how you do. All right, let's see how you did here. And that is solving for x. That is, what's this distance right here? Well, we could say let's write 5 under the square root sign of 25. And we could write 10 under the square root sign of 100 because those are the same numbers. They live at the same place on the number line. 100 minus 25 is 75. The square root of 75 is the length of x. And that's what this equation right here gives us. But the square root of 75 can be simplified to square root of 3 times 25. 25 then comes out from under the square root sign, and that leaves us with 5 square root 3. All right? Read it, think about it, click on the stop sign. Let's see how you did. Triangle congruency theorems say that if the sides are all the same length, then, and we can think of that as side, 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 or SSS, if the sides are all the same length, then the triangles are congruent. Click on the stop sign. Okay, the triangle congruency theorem tells us that if one side, the angle between that side and the other side are all the same, then we call that the side angle side triangle congruency theorem, or it could be abbreviated as SAS, or you can even say it backwards, SAS, and it's still the same. So if this side is equal to the length of that side, this angle is the same as this angle over here, and this side right here is equal to that side right there, the triangles are congruent. Congruency means that they are the same size and shape. All right, what triangle congruency theorems makes them congruent? Click on the stop sign. None. The angle side-side method doesn't prove congruency. Now, these two triangles do happen to be congruent. However, it doesn't prove that they're congruent if you go with the angle side-side method, and here's why. If you have the angle side-side method, this angle can be the same as this angle right here, and the length of this side right here can be the same as the length of that side right there. And the length of this side right here can be the same length as that side right here, but that doesn't mean that these two are congruent, because they are not. Find the exact lengths of the triangle below. Okay, you'll click on the stop sign. Now let's see how you did. H, well, we know that we're dealing with 30 degree, and you may recall that the 30 degree triangle, the 30, 60, 90, has this special property of if this is x length, this is going to be 2 times x, and this is going to be x times the square root of 3. So that means if this is 7, the hypotenuse is 14. If this is x, then it's going to be 7 square root 3. Now, you could then turn 7 square root 3 into a decimal equivalent, but that's not a perfect number. It's a decimal approximation. Find the exact lengths of this triangle. Click on the stop sign. All right. You may recall that the 45, 45, 90 triangle, whatever this leg is, the other leg of the triangle, right triangle, is also the same, and the hypotenuse is x square root 2. So that means if this is 3.3, this is going to be 3.3. And if this is 3.3, the hypotenuse is going to be 3.3 times the square root of 2. All right, this one's a little bit of a head scratcher, so click on the stop sign and give it a whirl. Okay, let's see how you did. First, I want to find the area of the circle, and then I'm going to subtract the area of the square, and then I'm going to divide my answer by 4. When I do that, dividing my answer by 4, that will give me this area right here, and that's what I need. So, now, we're going to say, find the area of the circle. Well, we have a diameter of the circle is 6, so that means its radius is going to be 3. Finding the area of the circle is just then going to be pi times 3 times 3, and that's going to be 28.26 units squared, correct to 2 decimal places. Finding the area of the square, well, we have a couple of ways of doing that. If this is going to be 3, then that's going to be 3, and that means that the outside edge of the square is going to be 3 square root 2. 3 square root 2 written in a decimal form is going to be 4.24, and this is only one of a few ways that you can solve this problem, is going to be 4.24. 4.24 times 4.24, in other words, length times width, is going to give me the area of the square. the area of my square is going to be 17.97 units squared if I find it with a decimal equivalent. Taking the area of the circle, subtracting the area of the square, and then dividing my answer by 4 gives me 2.57 units squared as my final answer. If you had said, okay, what I need to do is recognize that this is 3 and that is 3, the area of a triangle is 3 times 3 divided by 2. That means this would be 4.5 units squared exactly. And then I multiply it times 1, 2, 3, 4, and this number right here would have become 18, which is more exact than me using the decimal equivalency of 4.24. All right, click on the stop sign and give it a whirl. Let's see how you did. Well, if this is 45 degrees, if this is 90 degrees right here, then that means the rest of it is 3/4 of the circle, or 270 degrees. Half of 270 degrees then is 135 degrees. So I have 135 degrees divided by 360 degrees. It turns into this decimal, and then if I shift the decimal 2 places, then I wind up with an answer of 37.5%. Or you could have looked at it and said, okay, this 90 degrees is 1/4 of the circle, and 1/4 of the circle means that I have 3/4 left over. If I have 3/4 left over and the white and the black area are the same, 3/4 cut in half is going to be 3/8, and 3/8 is then going to be turned into this kind of a decimal right here, and then I shift the decimal 2 places and I wind up with exactly the same answer. All right, slightly different problem. Just click on the stop sign, see how you do. All right, well, we have 135 degrees plus 90 degrees, and so that's 135 plus 90 over 360, not 365, an error on my part, 360, and that gives us 0.625. Shift the decimal 2 places, and it becomes a percent. Percent means per 100, and so we have 62.5 per every 100 that we have. Below is the illustration. Click on the stop sign, see if you can solve this one. All right, let's see how you did. Well, I need to do several things here. Find the area of the circle, find the area of the triangle, find the area of the difference between the two, and then that would be 1/3. Then I want to find the percentage that this gray area is of the total circle. And so that means once I know this gray area right here, then I use that as the numerator, and then the total area of the circle is my denominator. And so we'll deal with that. So let's see, area of the circle, how do we find that? Well, it says that it has a radius of 1, so it's just 1 times 1 times pi. That means the area of the circle is 3.14 units squared. The area of the triangle maybe is a bit more challenging, but if I draw a line from the vertex to the midpoint of the other side, and I draw a line from the vertex to the midpoint of the other side, that line, those 2 lines will meet at exactly the center of the triangle. And since I have a regular 3-sided equilateral triangle, the center of it happens to be the center of the circle, which means that the radius of 1 now becomes the hypotenuse of a right triangle that I have right here. And since this was 60 degrees, half of that is 30, so I wind up having the 30, 60, 90 triangle, this being 60, which means that if this is 1, then that means this is 1/2, and then that means that this right here is 1/2 square root 3. I now have enough information to calculate the area of this triangle. Then I will multiply it times 6 because I have 1, 2, 3, 4, 5, 6 congruent triangles. Then I know my area of the triangle. So I have the area of the circle minus the area of the triangle gives me this. divide that answer by 3, and this gives me this for the gray area. That's my numerator. Put that over the denominator of the area of the total circle, and I come up with 0.196 and move the decimal 2 places, and that's 19.6%. All right, click on the stop sign to see how you do. The triangles are proportional, but the question is, what's the area of both? And the area of both means that you have to find the area of both of them, and so the correct answer is 9.75. 2 is to 3 as 3 is to x. I can set up the proportion here. 3 times 3 is 9, and 2 times x is also going to be 9, so x is going to be 4.5, and then that allows me to calculate the area of this triangle. And the area of this triangle was pretty straightforward. It's just 2 times 3 divided by 2. Add those two together, and I come up with 9.75 units squared. Okay, convert 1 square foot into square centimeters. Click on the stop sign. All right, let's see how you did. The way I did this, and you have multiple ways of doing it, was I drew a picture. I drew something that was 1 foot square. And if it's 1 foot square, it's also going to be 12 inches square, 12 by 12. And since 1 inch is defined by the United States Congress as 2.54 centimeters, that means I multiply 2.54 centimeters times 12, and 12 inches and 1 foot are also 30.48 centimeters. 30.48 centimeters times 30.48 centimeters gives me exactly 929.03 centimeters squared for exactly the number of centimeters, square centimeters, in 1 square foot. Okay, click on the stop sign, give it a whirl, and see how you do. Okay, here's the way that I did this. Was I drew, not a very good drawing of that, it's hard to draw with a mouse. I drew a septagon, a 7-sided figure, a regular 7-sided figure, and regular means that all of the lines are going to be the same length and all of the angles are going to be the same. So I sketched it, and then I calculated the internal angle. I calculated the internal angle. Let me change the color here so that maybe you can see what I'm doing better. I calculated the internal angle by drawing from the center to each vertex. Then I realized that this is 1/7 of 360 degrees, and so 360 divided by 7 is 51.42. Knowing full well that every triangle in the known universe and beyond has an internal angle measure of 180, I took 180 and I subtracted from 180 51.42. And then I took my answer that I got from that and I divided it by 2. And so in order to divide that by 2, I came up with this angle right here, which is also congruent to that angle right here. Adding those back together, I come up with that the single internal measure is going to be 128.58 corrected 2 decimal places. I know that this angle right here is going to be congruent with this angle right here, and so adding 64.29 to 64.29, I also get 128.58. There's a formula for this, but I think it's more important that you be able to draw out the picture and visualize it, because if you use the formula and you don't understand what it looks like, you can get the wrong answer and not even recognize that you have the wrong answer. All right, you have a dartboard, a circular dartboard, and it's divided into 4 equal sections. Read the question after you click on the stop sign, and then come back and see how you did. All right, let's see how you did. I didn't do a very good job of drawing a circular dartboard that was in 4 unequal sections, but I drew a picture. So I was able to then come in and say, all right, I have a picture of a dartboard, a round dartboard, that is in 4 sections, and if this is x degrees, then that means the next section is going to be 2x degrees, and the next section is going to be 4x degrees, and the next section is going to be 8x degrees. And if I add these up, 1 plus 2 plus 4 plus 8, I get 15x's is equal to 360 degrees. Divide both sides by 15, and I get x equals 24. So that means this section right here is going to be 48 degrees. All right. What's the probability that a dart thrown at the dartboard in problem 17 would hit section 2? Remember that the section 2 was 48 degrees. Click on the stop sign. Okay, let's see how you did. Well, I can put 48 degrees over 360 degrees. I have degrees in the numerator and degrees in the denominator, so they cancel out. So I could look at this and say, all right, there's the probability, 48 out of 360. But if I do the long division here, I'm going to come up with this decimal equivalent. And then if I shift the decimal 2 places, I wind up with 13.3% out of 100. Okay, and let's see. Click on the stop sign and see how you do. All right, let's see how you did. If you recognize that they were proportional, then that means that whatever this angle is, this angle here is going to be the same. Whatever this angle is, this angle right here is going to be the same. So, since they wanted to know what theta was, then you would really just be needing to know what this is. You don't even have to use anything here to calculate that, because you're able to look at this and say this is the inverse tangent function of 5 divided by 6, which gives you 39.8 degrees. All right, click on the stop sign and see how you do. Let's see how you did. If I have, and I just drew a picture here, and so I have a diagonal measure of 12 inches, which means that this is 6 inches and that is 6 inches, which means that this side right here is 6 square root 2, and 6 square root 2 times 6 square root 2 gives us 72 inches squared. Another way of looking at this without dealing with the square root would be for you to come in and say 6 times 6 is 36, divided by 2 is 18. So this triangle right here is 18 units squared, and there are 4 congruent triangles, so 4 times 18 is also 72 units squared. 2 ways of solving the same problem. All right, click on the stop sign, see how you do. Okay, if we have a square, I drew a picture here, and I would highly encourage you to draw a picture. We have a square with a diagonal measure of 15 centimeters, which means that this is 7.5 centimeters, which means that this length right here is going to be 7.5 centimeters times the square root of 2 centimeters long. And they want to know the perimeter, so if I have the perimeter, which is just the total area around, I multiply that times 4, and I wind up then with 16.7 inches. How it is that I went from centimeters to inches, I simply multiplied my answer times the number 1, and that is 1 inch over 2.54 centimeters. I have centimeters in the numerator, I have centimeters in the denominator. They cancel each other out, and now I wind up with 42.42 times 1 inch divided by 2.54, the pure number, because the centimeters have been canceled, and that gives me 16.70. I could have said, all right, I know that my answer needs to be in inches. I could have said, what I need to do is convert 15 centimeters into inches and then solve the problem. I chose to convert at the end. You simply could have chosen to convert at the beginning, and you would have come up with the same number had you done everything correctly. All right, find theta, theta prime, and the hypotenuse. Click on the stop sign. Okay, let's see how you did. Theta is 52.1 degrees. Theta prime is 37.87 degrees. And the length of my hypotenuse here, well, I can rewrite 7 as the square root of 49. And I can rewrite 9 as the square root of 81. And so those are the same numbers. They live at the same place on the number line. I can then add the number 49 to the number 81, and I get 130. So I'll put that under a square root sign, and that gives me the hypotenuse is exactly the square root of 130, which is approximately 11.4 units long, whatever they are. Okay. Well, I've been kind of alluding to the fact that there is a formula for finding the sum of the internal angles of a regular polygon, and there's the formula right here, but I think it's a lot more important that you be able to draw a picture and then figure out what you're doing from the picture. So this is the sum of all of the internal angles, And here is kind of the formula or the equation, if you want to call it that. And so I take 180 times the number of sides minus 2 and crunch that out. So let's take a look at how that works in reality. If I want to know what the internal angle is of a three-sided polygon, also called a triangle, having its own special name, I then can simply say, all right, the sum is going to be equal to 180 times 3, the number of sides, minus 2. That means 180 times 1, and that's 180, so it works. All right, so what happens if you're dealing with something that is a four-sided polygon, also called a square? Well, the n becomes a 4 minus 2. 180 times 2 is 360, which is the total number of internal degrees for a square. What happens if you're dealing with a five-sided polygon? I'll let you work on this one. Click on the stop sign. All right, let's see how you did. There are 540 total internal degrees, but then if you want to know how much each one of them is, you have to divide the whole thing by 5, and you come up with that one of the internal degrees of the five-sided polygon, also known as a pentagon here, one of those is going to be 108. This will be 108, and that will be 108. All right. Below is a three-sided regular polygon. Click on the stop sign and try to work it out. Okay, if this is an equilateral triangle, then that means that's 60 degrees. And if that's 60 degrees, then you know this is 180 degrees, which means that that is 120 degrees. And this is 180 degrees right here. And those are all degrees. And that's the way that works. All right, we could have then used some sort of a formula, but the trouble with using a formula like this is that you might get an answer, but if you don't know what it looks like, if you haven't visualized it, then you're kind of out of luck, because what happens is you get an answer, but you don't know what it looks like. So I'm going to highly encourage you to draw a picture if you want to know what something looks like. All right, collinear points. Click on the stop sign, see if you can solve this problem. Well, it turns out that collinear points are two or more points that fall on a straight line, and that's the definition. So if I have just 2 points that are given, these 2 points aren't collinear, and these 2 points aren't collinear because any 2 points are on a line, but when you have more than 2 points and they fall on a line, they are called collinear. Click on the stop sign, see how you do. All right, well, I drew a picture. I drew a hexagon, and then I divided the hexagon up into equal parts by just saying, okay, there's about the center, and I'll draw a line out to the vertex, and there's a center, I'll draw a line out to the vertex. And if I do that to each one of the vertexes, I then wind up with 6 equal-shaped pieces. And those 6 congruent triangles that are there, I then divide 360 by 60 because one of those triangles is 1/6 of the 360. So that means this is 60 degrees. That means this angle right here is going to be congruent with this angle right here. And that also means that these 3 angles are going to have to total 180, which means that this is 60 degrees and that is 60 degrees, and this is congruent with that. And so that winds up meaning that this internal angle right here is 120 degrees. Now, I could have used the little formula for that, and I come up with the same answer, but there's a lot of opportunity to make a mistake, and if I don't know what it's supposed to look like at the end, I'm not able to tell whether or not that's the right answer. I just get some number that is actually kind of foreign to me. All right, I call this the cat food logic problem. So using the grid, see if you can tell the width and height of the cat food. All right, let's see how you did. Well, it turns out that if each one of these, this grid right here, that's 3/4, that's 3/4, that's 3/4, that's 3/4, and that's almost a little more than half of 3/4. And so this little portion right here and this portion right here total up to about 1. It's not perfect, but it's an approximation. So I wind up having 1, 2, 3, 4, and apart, that's 5. So my cat dish is about 5 wide, but 5 times 3/4. So multiplying 3/4 times 5, which is just multiplying a fraction times a fraction, because 5 is just a fraction over 1. I can think of it like that. And so 5 times 3 is 15, and 15 over 4. Simplifying the fraction here, I get 3 3/4 wide. And then how tall is this puppy? Well, let's see. I have a portion here, and then I have a full one here, and a full one, and a full one, and then a portion again. So I have, we'll just call that 1, 2, 3, 4, and so it's a 4 high, or very, very close to 4 high. So 4 times 3/4, 4 times 3/4 is the same thing as 4 over 1. So I'm multiplying a fraction times a fraction. 4 times 3 is 12. So it becomes 12 over 4, which simplifies to 3 inches. So how wide is it? It's 3 3/4 inches wide. How tall is it? It's 3 inches tall. Okay, a circle has an infinite number of sides and is technically not a polygon because each part of the circle isn't a straight line. So what is the opposite of a circle? Well, it turns out I will say that the opposite of a circle is a triangle. This has an infinite number of sides, none of them being straight lines, and this has the minimum number of sides for a two-dimensional object, a polygon, and so I'm going to say that the opposite of a circle is a triangle. Your comments, questions, and suggestions are always welcome, encouraged, and appreciated. You may write to me at alanmorris@yahoo.com.